Hello, this movie is for Unit 6, Learning Target 8, Conditions for Rhombuses, Rectangles, and Squares. Our first theorem we're going to look at is if a diagonal of a parallelogram are perpendicular. So when we have perpendicular diagonals, then the parallelogram will be a rhombus. So if we know it's a parallelogram and the diagonals are perpendicular, then we can say it's a rhombus. We can conclude all four angles or all four sides are congruent. We're going to cross out that proof. Two more theorems, two more properties. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So here, the only condition that's necessary is that one diagonal bisects the opposite angles. Then it's a rhombus. Next theorem, if the diagonal of a parallelogram are congruent, so when you have diagonals both equal to each other, congruent, then the parallelogram is a rectangle. You'll start to notice that these seem to and feel like the converse of theorems we've had in the past. So this is allowing us to say that specifically this parallelogram is a rhombus because of certain properties, and this parallelogram is a rectangle because of other properties. Can you conclude that the parallelogram, so we're given that it's a parallelogram, is a rhombus, rectangle, or square? Let's look at the first example. We have one diagonal and it's bisecting opposite angles. So yes, we can conclude that this is a rhombus since diagonals bisect opposite angles. So we know it's a rhombus because we have a diagonal that bisects opposite angles. Let's look at B. Here we have that the diagonals here and here, they are perpendicular. Because diagonals, I'm going to bullet this, are perpendicular, that tells me that the parallelogram, because it's given that it's a parallelogram, the parallelogram is a rhombus. So when diagonals are perpendicular, you know that the parallelogram is a rhombus. We also see that the diagonals are congruent to each other. That makes it a rectangle. Now, when a figure is both a rhombus and a rectangle, we call it a square. So this is yes, it's a square. Since it is both a rectangle and a rhombus. Let's look over here. 1A. A parallelogram has angle measures 20, 160, 20, 160. Can you conclude that it is a rhombus, rectangle, or square? Well, let's see. We've got 20, 160, 20, 160. So if I draw this and I put 20 here, 160, 20, 160, we can see that this is definitely a parallelogram. Could it be a rhombus? Well, this one's not. If I brought them in so that all four sides are congruent, it could still have 20, 160, 20, 160. So it might be a rhombus. But it might not. So can we conclude that it is? No. But it might be a rhombus. Because here I could have these guys congruent and these guys congruent, and that is not a rhombus. Let's look at B. Suppose the diagonals of a quadrilateral bisect each other. So there's A. Let's look at B. Can you conclude that it's a rhombus, rectangle, or square? So diagonals of a quadrilateral bisect each other. Well, if I did this, where it's a rhombus, we know diagonals bisect each other. In a rectangle, they also bisect each other. So the reason why that works for those two, and therefore a square as well, is that because that's a property of a parallelogram. So the answer is no. The fact that diagonals bisect each other sorry about that, bisect each other is a property of all parallelograms. All parallelograms have that to be true. Let's go over here. For what values of x is parallelogram ABCD a rhombus? Well, what we know is in a rhombus, the diagonal bisects opposite angles. So what I know is that 6x minus 2 must be equal to 4x plus 8. So we're going to solve this. Minus 4x and add 2 and divide by 2. And we get x is 5. So what value of x? When x is 5, parallelogram ABCD is a rhombus. For what values of y is parallelogram a rectangle? Well, what we need to do is use properties of a rectangle. And we know that because it's a rectangle, the diagonals are congruent. Well, I'm only given half the length of the diagonal. The other property we know about a rectangle, is that a rectangle is a type of parallelogram where the diagonals are not only congruent, they bisect each other. So because of that, all 4 of these segments are congruent to each other. We would set 5y plus 3 equal to 7y minus 5. And we get 4 is equal to y. So when y is 4, we have a rectangle. Now you might notice, because it's a parallelogram, that you could put 5y plus 3 here, 7y minus 5 here, and do 2 of the 5y plus 3 is equal to twice the 7y minus 5. And solve that, you'll also get y equals 4. Here are some extra problems for you if you'd like to practice this idea. Otherwise, that's the end of the movie. Thank you for watching.